Hello folks, today we are going to factor, and there's several different types of factoring that we're going to do. GCF, we're going to look at factoring of perfect squares and factoring conjugates and factoring generic trinomials. So this is going to be a great time, so sit back, buckle up, and let's have some factoring fun. So to factor out a GCF to start with, we're going to practice some of our distributive property skills because factoring a GCF is working backwards from the distributive property. So remember, what we did is we took the term that was in front of the parentheses and multiply it one piece at a time by each term that's inside the parentheses. So this x squared now becomes 2x to the fifth, because when you multiply terms, you add the exponents. And then we do 2x to the cube times negative 3x. So that becomes minus 2 times 3 is 6. Add the exponent. And then when we distribute to the 6, we get 12x to the third. So a GCF is going to start with the terms and end with the piece out in front of the parentheses. So what I am going to show you is how to find that common term that can be taken away from each of the three original parts. Okay, so if you want to practice your distributive property one more time, pick one of these examples, pause it, and go ahead and distribute. But I am going to jump, excuse me, I am going to jump right into our factoring. So finding a GCF, like I said, is the opposite or backwards from using the distributive property. So let's pretend that we have something that we're going to distribute. We're going to distribute a 4n to the fifth. And our end result, we already know, is 12n to the ninth minus 16n to the seventh. What would I need in this first blank so that 4n to the fifth would get multiplied by something and end up with 12n to the ninth? Well, in order to figure that piece out, I can take the 4n to the fifth and divide it into the 12n to the ninth. So 12 divided by 4 means I need a 3 here. That way 4 times 3 makes the 12. And subtracting the exponents on the variable, 9 minus 5, means I need an n to the fourth in here. That way the n to the fifth times the n to the fourth gives us what we needed for an answer, n to the ninth. Let's do the same thing with the second piece. If I need to end up with a minus 16n to the 7, what times 4 makes a negative 16? So I'm going to take my negative 16n to the 7th and divide it by the 4n to the 5th. So negative 16 divided by 4 is minus 4. And subtracting the exponents again here, 7 minus 5 is n to the second. So that is how we figure out what goes inside the parentheses. So why don't you take a pause on the video, try to fill in the blanks for the next one, and then we'll see how you did. So what we're going to do is take the GCF and divide it into each term. 2x to the third y squared minus 2x to the third y squared. Divide the numbers, subtract the exponents, and do that for both. 8 divided by negative 2 is minus 4. Subtract the exponents. And if the exponents match, that means they cancel out and there's no more y written. So the next issue is, how do I figure out the GCF, the part that goes out in front? Because once we know that part, now we know just to divide it into the terms that were given in the expression that's supposed to be the answer. But how do I get that GCF in the first place? So we can use the calculator to help us with this. Now, depending on which version of the calculator you have would make it a little bit different with the buttons you push. But I have my Inspire here, And I just go to my regular calculator screen. Remember, if you have, if you hit the home menu, the home button, the on button, then you can hit A, and that'll get you to your regular calculator screen. So the menu button will give us a list of options, and we want actions. Okay, we want option 1, the actions, and we are going, I'm sorry, option 2, numbers. Because we're looking for a GCF of numbers, so we can go to menu, and then option 2, numbers, and then option 5 here. Option 5 here, greatest common divisor. GCF, the calculator says GCD, but means the same thing, all right? So the numbers for our problem are 4 and 2, because I have a 4 in front of my x squared and a 2 in front of my x to the 5th. So greatest common divisor of 4, comma, 2, and then enter. Now these numbers are easy. You might not need the calculator to help you determine that 2 is the greatest common factor between 4 and 2. But as the numbers get bigger, this is a nice way to help yourself out. If you have one of the Texas Instruments graphing calculators, an TI-84 or an 85, I think the 86 is probably similar, or even one of the older ones in 83, we can go to the math menu, over to number, right here, and in our list, GCD, number 9, greatest common divisor. Okay, but we want to do this from the regular home calculator screen. So again, that was the math button. Hit the right arrow to over to get number, and then option 9 is GCD, and then put in 4. The comma here is above the number 7, and we can find it that way. So if you don't have calculators, then the long way to do this is to look at all the different factors of 4. So there's 4 times 1 and 2 times 2. And the numbers that multiply to get 2 would be 2 times 1. So you look at the two lists, and what's the largest number between those two lists? And that's 2. Calculator did it for us, though. When you're looking at the greatest common factor for variables, so both terms have the letter x, the variable x, you take the smallest exponent that's in common between the two variables. So it's x second or x to the 5th. The smaller of the two is x to the 2nd. So our greatest common factor is 2x squared. So if we were told to factor this, we would put the 2x squared in front of the parentheses. There were 2 terms to start with, so I have 2 blanks inside the parentheses. Then I take the original term, divide it by the greatest common factor to figure out what should go in the parentheses. So 4 divided by 2 is 2. The x squareds and the x squareds cancel out. Next piece, 2 divided by 2 is 1. And subtract the exponents, makes it x to the 3rd. So that would be the GCF factored form of those given 2 terms. So let's try another one. We want to find the GCF between 9x cubed and 27x squared. So we need to find the GCF of 9 and 27. So on my Nspire, I go to menu, I go to option 1 or option 2. Sorry, I go to menu, option 2 for numbers, and then option 5 for greatest common divisor. And my numbers are 9, comma, 27. If we have the other calculator, we go to math, the math button here, go over to our number list, and option 9 is our greatest common divisor between 9, comma, 27. And we get the same result. So our greatest common factor starts with a 9. Then you look at the common variables and take the smaller exponent. So I have x third and x squared. I use x squared. That is our greatest common factor that goes in front of the parentheses. And then I divide each of the original terms by my greatest common factor, and the results are what I use inside the parentheses. 9 divided by 9 would cancel. Subtract the exponents, and I get x to the first, which is just x. 27 divided by 9 is 3, and the x squareds would cancel out. And there's our factored form. So now let's do some practice with these. All right. We got AB minus BC. The GCF, greatest common factor, is whatever can be taken out of all terms. So they both have a B in common. So B is the GCF. There are two parts to my original expression, so there will be two pieces inside the parentheses. So if I take my original AB term, divide it by the GCF of B, the B's cancel out, leaving me with A. If I take the BC term, divide out the GCF of B, the B's cancel out, and I'm left with minus C. And there's our factored form. So number 2. 8 and 4 have a GCF of 4. You can either get that from your calculator or just using your number sense. Both terms have an x cubed, so that's included in my GCF. The first term has a y squared, but the second term does not. So then that's it for my greatest common factor, because there's no y term in common with both expressions, both terms. There were two terms in my original expression, so I will have two parts inside the parentheses. So now I divide the original term by the GCF. 8 divided by 4 is 2. The x's cancel out, and I keep the y squared. Notice that the 4x cubed divided by 4x cubed perfectly matches, so everything cancels. I hold that place with a plus 1. Next example. 20, 30, 30 will have a GCF of 10. And the last 30 does not have an x with it, so 10 is our only common factor. The original expression had 3 parts to it, 3 terms, which means inside my parentheses I will also have 3 terms. I'm dividing each of these by the GCF of 10. So I'm left with 2x to the 4th minus 3x plus 3. Now to check any of these, you can just use your distributive property and multiply it back in, and you should get back to where you started. Okay, so pause this, try number 7, and then we'll see how you did, and then move on. Pause it, try it, and then come back. Welcome back. Hopefully you did it right. I found the GCF was 2. They both have an x in common and a y in common, so it's 2xy. Divided the 2xy into each of the 2 original terms, and I had my final factored form. Next, we're going to factor perfect squares. Now, a perfect square means something squared, something times itself. So, before we factor perfect squares, let's practice multiplying perfect squares. Now, a perfect square is something times itself, so x minus 9 squared technically means x minus 9 times the second x minus 9. When we did work earlier in this course, we used the box method to multiply two binomials. X times x is x squared. X times negative 9 is negative 9x. X times negative 9 is negative 9x again. And negative 9 times a negative 9 turns into a positive 81. So then to get your final answer in standard form, which means the highest exponent term goes first, that's x squared. Nothing combines or matches with it. There are 2 minus 9x's, so that means minus 18x, and then plus 81. So what happens here is the last term or the second term in the parentheses, negative 9 times negative 9 makes the last number of 81, and negative 9 times 2, or negative 9 minus 9 more, like these two boxes, get you the middle number. So the middle number comes from addition of the 9 and 9, and the last number comes from the multiplication of negative 9 times negative 9. So let's try that again. So I want you to do r plus 10 squared, which could be written as r plus 10 times the second r plus 10. If you'd rather use the double distribute or FOIL, you may, or you can use the box, but I want the final answer of the product of r plus 10 times r plus 10 written in standard trinomial form. So pause it, multiply it out, and then we'll see how you did. Okay, so there it is. We did r plus 10 times r plus 10. So r squared, the 10 plus 10 added up together to be the 20 in the middle, and then 10 times 10 gives us the 100 at the back. So now to work backwards from this. To work backwards from this, what we're looking for is a special number, same number that multiplies times itself to make 16 and adds to itself to make a negative 8. Well, for each of these examples, they all started out with x and x, the first piece in each parentheses, or in this case, r and r, the first number in each parentheses. So in order to get that x squared term, or the r squared term, I'm going to need the same variable in the front of both parentheses. So what number times itself is 16? And then does that plus itself make a negative 8? So 4 times 4 is 16. How do I make it multiply to be a positive, but add to be a negative? And that's if they're both minus. Negative 4 minus 4 more adds to be negative 8. Negative 4 times negative 4 is positive 16. So as we're doing these factoring questions, what we're looking for is if the last number is a perfect square. So if I do the square root of 25, I get 5. Will that plus itself, or that times 2, make the middle number? If the answer is yes, then I know that it's plus 5 plus 5. Remember that the values we're looking for will multiply to be the last number and add to be the middle number. So pause it, try number 5, and come back. We'll see how you did. So this one ends up x minus 3, x minus 3. 3 times 3 is 9. Negative 3 minus 3 more is negative 6. Now, let's look at another special case, something called conjugates, difference of two perfect squares. Now, the word conjugate, if it sounds weird or confusing to you, don't lose any sleep over it. Conjugate means take a parentheses or a term that has a plus sign, x plus 3. The conjugate is the opposite, x minus 3. Okay, so they come in pairs, x plus 3, x minus 3, x plus 9, x minus 9. Look at the examples down the page. N minus 5, n plus 5. 8 minus y, 8 plus y. So it's the same numbers or terms in each parentheses, one with a plus in the middle, one with a minus in the middle. That's what conjugate means. So what we're going to do is see how these conjugates factor. Okay, they're called the difference of two squares. So we'll take our x minus 9 and the x plus 9, and let's multiply it out and see what happens. So x times x is x squared. X times negative 9 is negative 9x. X times positive 9 is positive 9x. And then positive 9 times a negative 9 is a negative 81. So as we rewrite this in standard form, the x squared comes first. But notice what happens next. The negative 9 and the positive 9, they cancel out and end up 0. So they go away. And the only other piece there is the minus 81. So when we had the same sign, minus 9 and minus 9, we had a plus 81 because a negative times a negative is always a positive. And then The two 9s combine for an 18 in the middle. We had 3 parts here, 3 terms. But when it's one of each, -9 and +9, the middle terms will cancel. And a negative times a positive is always a negative result. So if you see an expression that ends in a perfect square, there's 2 possibilities here. Well, a couple different possibilities. If there's 3 terms, like what happened on the last page, if there's 3 terms and the last number is a perfect square, you have to check to see if the square root of that last term adds up to be the middle number. Then we have our results. If there's only 2 terms, it has to be subtraction. The only way this works for a difference of 2 squares is if it's subtraction, because it has to be a +9 and a -9. They have to be opposite signs. They have to be opposite signs in order for the middle 2 terms to cancel. And if they are opposite signs, making the 2 middle terms cancel, a negative times a positive is a negative. All right? So multiplying these out should be very simple. If you notice that it's the same thing in both parentheses, 1 minus 1 plus, we square the variable, multiply -5 times +5, which is -25, and based on the example we already did, we know the middle term is going to cancel out. So 8 minus y, 8 plus y. We do 8 times 8 because the 8 came first. We continue to keep the number first. -y times +y is -y squared. 2k times 2k makes it 4k squared. +1 times -1 is -1. So knowing those, what we want to do is work backwards now and try to factor these difference of 2 perfect squares. Now they're called the difference of 2 perfect squares, difference meaning subtracting, and both 9x squared and -1, they both have to be perfect squares for this to work. Both parts have to be perfect squares for this to work. And the variable is a perfect square when it's an even exponent because it can be divided by 2. It can be split perfectly. So this will factor what times itself is 9, and that's 3 and 3. The exponent gets split in half, and then we do the square root of 1, 1 plus, 1 minus, to make sure that they are opposite signs. And that's how each one of these is taken care of. Factor. Square root of 49, 7 and 7. The x squared split in half, x1, x1. The 25 is a result of -5 and a +5. It doesn't matter if you put the plus first and the minus second. That doesn't matter. And then the y squared splits into y1, y1. So 4n squared minus 49. The 4n squared splits into 2n and 2n. And the 49 is -7, +7. Or if you'd rather, put the +7 first and the -7 second. If the exponents aren't just a 2, it's okay. You just divide the exponent by 2, and that's your new result you use in the parentheses. So the square root of 36 is 6 and 6, and the exponent on the a is a 4. That gets split in half. 2 in the front, 2 in the back. The b fourth, the exponent also gets split. B squared in the front, b squared in the back. All right, so take a few minutes, try these next 4 examples, and then let's come back and join me, and we'll see how you did. All right, welcome back. So 1 squared is 1, 36 squared is 6, and the t splits into t and t, 1 plus, 1 minus. 16 squared is 4 and 4. You take the exponent of 6 and split it, so 4m3, 4m3. And then the 9k6 minus 3k to the third plus 3k to the third. Now on your calculator, you can do the square root of 121. If you weren't sure where or if that number is a perfect square, you can do the square root of 121 on your calculator. That's how I got 11 and 11. And even if there's more parts to it, just take it one piece at a time. The square root of 64 is 8. Split the exponent in half. The square root of 81 is 9. Split the exponent in half. All right? That's the difference of two perfect squares. The last type of factoring today is going to go back to similar to what we did with our perfect squares up here. So we focused on what numbers multiply to be the last number in the expression. And then the same two numbers that multiply to be 81 had to add up to the middle number of negative 18. That's how we're going to do our standard trinomials. So if we look at or practice using the box method or maybe the double distribute property, the FOIL, we get x squared plus 7x plus 3x plus 21. So 3 times 7 multiplied to be this last term of 21. And when you write your final answer, you would add the 7 and the 3 to get the middle value. So when we're factoring, we're looking for two numbers that add to be the middle and multiply to be the last value. And that's going to happen every time we FOIL these out. Doesn't matter whether the signs are the same or different. So let's take a look at this third example over here. N times n squared. That's pretty standard. Then we have n times negative 6, then n times positive 8, and then positive 8 times negative 6. So as we combine like terms, yes, this is a minus 6 plus 8. So you can go to your calculator and type in negative 6 plus 8. We are still adding them together. We just happen to be adding a negative 6. So n squared stays n squared. Negative 6 plus 8 is a positive 2n. And then the minus 48 gets brought down. Same pattern. 8 and negative 6 multiply to be a negative 48. And then 8 minus 6 add to be a negative, or add to be a positive 2. And that's how we're going to work backwards with this. And we can have the calculator kind of help us with the multiplication part, because we're going to focus on that first. Okay? So let's get right into some of the factoring. I don't think we need more practice with the multiplying. So x squared minus 2x minus 48. So what we need to focus on first is what numbers can we find that multiply to be negative 48. And the same two numbers that multiply to be a negative 48 are supposed to add to be a negative 2. If we find these numbers, then we know our factors. So here's what we can do. We can go to the calculator. I'm going to use the old school calculator first. On the calculator, if you go to the y equals part, clear out whatever's there. We're trying to find two numbers that multiply to be 48 and somehow add to be a negative 2. So I'm going to type in 48 divided by x. Similar to how we simplified the square roots, simplified the radicals. I'm going to hit second and then graph, which gets me the table. So what I'm looking for here is two numbers that would somehow combine to create a negative 2. So 12 plus 4 makes 16. That's not negative 2. 16 plus 3. That's not negative 2. So I'm going to go down because I need two values that multiply and create somehow a negative 2. Now, if I remember correctly, they have to multiply to be a negative 48, which means one of them's positive, one of them's negative. That means I already know for the setup of my answer, x squared gets split in half, x and x. Because the two numbers that I'm looking for have to multiply to be a negative 48, I know that one of them's positive and one of them's negative. That's the only way I can have two numbers multiply to be a negative result, is if it's one plus and one minus, one of each. So somehow, somewhere in here, in this table of values, I need to put in the right number. Ha, that would help, huh, guys? So let's make this negative 48 divided by x, because they have to multiply to be a negative 48. So that means the table will now show a better accurate spread. Look at this. Negative 6 times positive 8 is negative 48. And negative 6 plus 8 would be positive 2. We need a negative 2, which kind of makes me think that I can use the same numbers, but switch which one's positive and which one is negative. Now, 6 plus negative 8 is negative 2. 6 times negative 8 is negative 48. So my numbers would be 6 and negative 8, which means my factors are positive 6 and negative 8. All right, so let's do that a couple times in practice. If you think you know what you're doing, then you can go ahead and just try these and then fast forward to make sure you're doing them right. But I'm going to go through some more examples to help you out and just to clarify. All right, so here we go. Let's do, what do you think, guys? Let's do purple. I like the purple. So we are looking for two numbers that multiply to be 36, and they have to add to be 13. So you might want to think about this in your head, or we can go to the calculator. So on the calculator, I can go to y equals. This time we have a positive 36 for our multiplication number and a positive 13 for our adding number. So I'm going to clear out what I had and put in 36 divided by x. Then I'm going to go to my table and look for a pair of numbers that add up to 13. If I have my Inspire, what I'm going to do is go and hit the graph button so I can get to a graph where I can put in a function. This is the Inspire's version of y equals. So here's where I type in 36 divided by x. Enter gives me a picture. Picture doesn't matter. I want to hit Control T to see the table of values. Here's my table of values. Find two numbers that add up to 13. 36 plus 1 is 37. 18 plus 2 is 20. 3 plus 12 is 15. 4 plus 9 is 13. There we go. 4 plus 9 is 13. So that means over here it was 4 and 9, making it x plus 4, x plus 9. Got it. Moving on, do it again. I want two numbers that multiply to be a positive 20, and then those same two numbers somehow have to add up to be a negative 9. So we can go to the calculator, either the Inspire or your TI, whatever you have. And there's a couple options. I can go back to my graph, and what I want to do is get a new entry. So F2 was, I forgot my number. What are we doing here? 20, positive 20. So we want 20 divided by x. 20 divided by x. To enter. And then we have our table here. I'm going to use this drop down arrow, use my cursor, get this drop down arrow, and select F2, and there's my 20 divided by x. Now somehow I need my two numbers to combine to be a negative 9. So if they're going to multiply, you got to think about this logically. Two numbers that multiply to be a positive. If they multiply to be a positive, then they have to be the same sign, either negative, negative, or positive, positive. If they multiply to be a positive number, the options are plus times a plus or negative times a negative. And if they have to add to be a negative, then that means they both have to be a negative number. So going back to my calculator, I'm going to head towards the negative numbers. Negative 21, that would give me negative 12. That's not a whole number, so that doesn't count. Negative 4 minus 5 more than negative 9. Boom, got it. So it's negative 4 and negative 5. Minus 4 minus 5. All right, do some more examples. If you want to pause it and then try it and then come back, or just follow along with me and we will do it together. Two numbers that multiply to be 7 and the same two numbers have to add up to be 8. We can go to the calculator, go to our y equals, and then they have to multiply to be 7. So we do 7 divided by x. Check the table. 7 plus 1 is 8. So this one is just 7 and 1. X plus 7, x plus 1. And if you wrote it as x plus 1 first, then x plus 7, that's totally fine. So all these examples are done the same way. We've been doing this for almost 36 minutes. A lot of different factoring here. Go back and rewatch it as often as you need. Pause it, whatever you need to do. I'll finish out a couple more examples, but feel free to go ahead and start your homework and start the skills check. Okay, so I need two numbers that multiply to be a 10, and the same two numbers have to add up to be a negative 7. So we can go to the calculator, and we can type in 10 divided by x, and look at the table. If we have our Inspire, I can add in a new function. So either way we do it, we're looking for two numbers that multiply to be 5, multiply to be 10, and add to be negative 7. Similar thinking to the other questions. A gets split in half, so it's first and first. And then if the 10 is a positive, that means both the numbers we're looking for will have the same sign, either both negative or both positive. Since the 10 is positive, and our numbers have to have the same sign, they have to match the middle. So it's going to be minus, minus. And after the calculator work, or a little bit of mental figuring, 5 times 2 is 10, and negative 5 minus 2 more is negative 7. So it would be negative 5 and negative 2. Next one, as we're moving along, what multiplies to be negative 15 and adds up to be negative 2? So if you think about the factors of 15, what numbers multiply together to get 15? It's a small list. 1 times 15, 5 times 3. So how does the 5 and 3 combine? How could they combine to make a negative 2? It would have to be negative 5 plus 3. And we can get the same values from the calculator. But once we know those numbers, then we have our factors. And then we're good to go and move on to the next question. So in this time, what multiplies to be negative 12 and adds to be a positive 4. Now, in order to multiply to be a negative number, using our basic number sense, I know right off the bat that one of these parentheses needs a positive number and one of them needs a negative number. So now you have to think about what numbers multiply to be 12 and how could a pair of those numbers subtract, even though it says add, one of them's a negative. So if they're opposite signs, that means our numbers actually subtract to be 4. So two numbers that multiply to be 12 and then subtract to be 4. Let's see if we can find a pair. There's 12 times 1, 2 times 6. Oh, look at that. 2 times 6 is going to work. Because if I had 6 minus 2, that would equal positive 4. And then 6 times negative 2 multiplies to be negative 12. So there we go. Now the calculator might help get those numbers faster, but I was just going through my head in the list of numbers that multiply to be negative 12. And as I go through that list, I figure out, will they make somehow a 4? When I find it, then we got it. Last two. So what multiplies to be negative 6 and adds to be, in this case, a positive 1. Since our numbers have to multiply to be a negative 6, I know already that one of them's positive, one of them's negative. The numbers that multiply to be 6 are 6 times 1, 3 times 2. So 3 and 2 could make a 1 if I did 3 and negative 2. And then 3 times negative 2 would also make the negative 6. So positive 3, negative 2. That's it. And our last one, bigger number this time, multiplied. Two numbers that multiply to be 144. And the same two numbers are supposed to add to be a negative 7. So since they multiply to be a negative, I already know that it's going to be y plus in one parentheses and y minus in the other parentheses. So now we have to figure out what numbers multiply to be negative 144. So I'm going to go back to my Inspire. I'm going to click off the table. So I'm going to click onto my graph screen. And then once I've clicked onto my graph screen, now I can hit Menu. And choice 3, do a graph entry. That is a function. So now I can type in my number, negative 144 divided by x, and then hit enter. And then back over to my table, I hit the little drop-down menu so I can choose function 3. Now here's my table of values for negative 144. We need to find a pair of numbers here that would add up to negative 7. So sifting through my list here, trying to find a pair of numbers that would somehow add to negative 7. The first thing I see is negative 9 and positive 16. Those would make a positive 7. So then if I just switch the signs, I would get the negative 7. So back over to my work, that means I need a positive 9 and the negative 16. 9 times negative 16 is negative 144. And then 9 minus 16 is the negative 7. And we are done. Sorry this was so long, but factoring is one of those tricky things that there's a lot of different types of factoring to do. But I hope you're okay, feeling a little better. Now go do some practice. Good luck. Talk to you soon.